Hello everyone. So in today's lesson, what we're going to do is we're going to continue on from what we did yesterday in finding a solution for simultaneous equations. So for today's example, what we're going to do is I'm going to solve the equations y equals 2x minus 2 and x plus y equals 4 graphically. So to do this, what we're going to do is we're going to find the x and y intercept. So I'll just kind of draw a quick sketch up here. So there's my Cartesian grid right there. If I were to draw just some line, so if I were to draw some random line, where that line crosses the x and the y axes, these are known as our intercepts. So that right there would be our y-intercept. And this right here would be our x-intercept. I forgot how to write it. Letter x for a second. That's my x-intercept. The x-intercept occurs when the value is 0, some number. So that would probably be like 0, 2. And that's where that point is. And then x-intercept occurs when the y value is at 0, and then there's some value for x. Maybe that's 3. So what we're going to do to find this today is we're going to set our values to 0 to find those locations and then use it to graph. So I'm going to start with this equation first. So I'll deal with this equation first, and I'll deal with this equation second. So for equation 1, so what we're going to do is we're going to find the x-intercepts for equation 1. So equation 1 is y equals 2x minus 2. So the first thing we're going to find is we are going to find the y-intercept. This is where the y is intercepting. So the line's intercepting the y-intercept, and our x value is going to be 0. So to find that, we're going to let x equals 0. Just like up here, x is 0, our x value is 0. So we're going to set this to 0 and find this other value. So to do that, we go y equals 2, bracket, we substitute in the value of 0 for x, minus 2. What's 2 times 0? 0 minus 2. And our y value is negative 2, because 0 minus 2 is negative 2. So our y-intercept is 0, negative 2. So there's our y-intercept. The next thing we'll find is we'll find our x-intercept. We'll use the same idea. So we're going to let y equals 0, because just like I said up here, where our line crosses the x-intercept, we have a value, and then our y value is 0. So I then say that 0 equals 2 times x minus 2. So then what I do is I move my value over. I go plus 2, plus 2. If I run out of room, I've almost run out of room. I'm just going to move things up a bit just so you can see. 0 plus 2 is 2. And then we still have 2 times x, which is 2x. I don't know why I put that in brackets. Sorry about that if that's confusing. These cancel out to make 0. So we have 2 equals 2x. That's not a z, that's a 2. So the next thing I have to do is I have to divide by 2. Divide by 2. And I get that x equals 1. So our x-intercept is 1, 0. So that's for all of equation 1. So we just know for our first line. For equation 2, we're going to redo that. So we have x plus y equals 4 is our second equation. I'm just going to move things up, and then I'm going to graph. Okay. So to do this, let's find the y-intercept. Again, to find the y-intercept, we're going to let x equals 0, just like before. So I'm going to say 0 plus y equals 4. What is 0 plus y? Well, it's y equals 4. So our y-intercept is 0, 4. That was easy. Next, we're going to find our x-intercept. Let's move it up a bit. And so we'll let y equals 0. So then we'll go x plus 0 equals 4. And what's x plus 0? It's pretty easy. It is going to be x equals 4. So our x-intercept would then be is 4, 0. So here's your x and y intercepts for line number 2, and here's your x and y intercept for line number 1. So we're going to use these now to graph. So I just happen to have some graph paper right here. So I'm going to graph my 2 lines in different colors, just so that way you can see it. You don't necessarily have to use different colors, but I'll use blue for line 1, and I'll use red. And you do not need to do this necessarily using 2 different colors. I'm just doing this so that way you can see. So I know it's hard to see. I'm going to zoom in a bit, and I'll see how. Oh, it's not actually that bad. Okay, so for line 1, our values were. I'm just going to take a second and put some pen caps on things so things don't dry out while I'm doing this. I'm just making it so I can see my locations. So we had our x-intercept being 1, 0. So that's 1, 0 is right here. So there's my first point. And then my second point is, I believe, 0, -2. So that's right here. So there's my line that I'm going to draw. And as soon as you have 2 points, you may draw a line. Use a ruler. Trust me on this, it's key to use a ruler on these drawings because you really need to make sure that they're accurate and they're done properly, so that way you can actually find the intercept, the shared point of the 2. So that's y equals 2x minus 2. Next thing we'll do is we'll then graph our other one. I believe my first point was my y-intercept was 0, 4, and my other one was 4, 0. I then take my ruler out and very carefully make sure to draw my line. Look at that beauty. And this was for x plus y equals 4. And now you can see the point of intersection very clearly is right here, and that's at 2, 2. So our solution is 2, 2, and that is our solution. So the point of intersection (2, 2), and that is our answer. So that's our solution. It's also the solution. X equals 2, y equals 2. So there's our solution. Let's try a second one. I have this one ready. I'm going to do a second solution. I'm going to do a second example just so you see 2. I want to make sure you get a chance to see 2, and I don't want you feeling like you didn't see enough examples. So there we go. So good. Again, we're going to use the exact same method. So nothing's going to change. So here's my equation 1. And equation 2 that I'm going to be finding the intercepts for. So equation 1. So what we're going to do is we're going to use 3x minus y equals 7. We're going to find the y-intercept. And don't forget we do that by setting or letting x equals 0. So then we go substitute that in. 0 minus y equals 7. Right? So then what we do is, what's 3 times 0? It is 0 minus y equals 7. That then becomes negative y equals 7, which isn't perfect for us because you don't want negative y equals 7. So we're going to, I'm going to divide by -1 and divide by -1. Y equals what? 7 divided by -1? It's -7. So there, we've moved our negative sign over. I'm just making sure my computer hasn't shut off because I don't want to lose this audio or this video recording. I think we're still good. It looks like I'm still recording. So we found our y-intercept to be 0, -7, and that's our y-intercept. Next thing we're going to do is we'll find our x-intercept. So we'll let y equals 0 this time. So that will be 3x minus 0 equals 7. We then go and we say 3x equals 7. Oh, this is going to be a little messy. Divide by 3, divide by 3. And x equals 7 over 3. And I know because it's going to be easier to graph, what I'm going to do is I'm going to change that to a mixed fraction, just so it's easier for me to graph, because I know that it's going to be easier overall to do. So I know that it's going to be equal to, I believe it's 2 1/3 will be a bit easier to graph. The next thing we'll do is we'll now deal with equation 2. I'm regretting the one I chose, but here we go. For equation 1, because we got a fraction, it'll be a little tricky to graph. Minus 4. So first we'll find the y-intercept. So y equals 2. 2 times 0 is 0 minus 4. 0 minus 4 is -4. Fantastic. Now let's find, so that's our y-intercept is 0, -4. And next our x-intercept. You still see? Nope, sorry about that. Intercept. We'll let y equals 0. So that will be 0 equals 2x minus 4. We'll add 4 to both sides. 2x equals 4 divided by 2 divided by 2. And then I run out of room, so that means that 4 divided by 2 is 2 equals x. That doesn't make any sense to me. I don't like the way it's written, so I can rewrite it as x equals 2, which makes a whole lot more sense. And my x-intercept then becomes 2, 0. So I now have 2 points. There's my x-intercept. So there's x equals, there's my x-intercept, there's my y-intercept. There's my x-intercept, there's my y-intercept. Now I'm going to take all that information and I'm going to graph. My graph paper ready to go. Again, I'm going to use different colors just for the sake of clarity. But for you folks, if you just label your lines, this is line 2 still. This is line 1. Because I still have the red pen in my hand, I will just graph line 2 just for fun first, doesn't matter which order you do it in. So my x-intercept was 2, 0, and my y-intercept was 0, -4, so that's good. I'll now take a second and draw my line. Here we go. I'm just making sure this all looks good. I'm just trying to make sure my line goes through those 2 points. Good. And that would be line 2, which was y equals 2x minus 4. The next thing I'm noticing is for my other one, I need another, I need to go just a little further down on my graph. I need to go to -7, because that's where my y-intercept is, I believe. Yeah. So, second graph, there's -7 right there, 0, -7, and then the other one is it's 2 1/3, so it's just about right there. It's very close. I'm trying my best in there. You could also do your x-axis by thirds if you needed to really make that exact. Let me just get that lined up there. Perfect. I have a nice point of intersection there. I can see it already. This was my second line, which was 3x minus y equals 7. Oh, time to move classes. Here's my point of intersection, and there's my point of intersection at 3, 2. Excellent. So my solution is point of intersection is 3, 2. Alright, I hope that's helpful to see 2 examples. Good luck in your practice. Take care. I'll also include a printout of this, so if you need graph paper, I'll include this in what I provide to you on Google Classroom. Take care.